Okay, this is 5.7 part 2. Sorry, you had to break it up in two. Um, we started to talk about Descartes' rule. It was a French man named René Descartes who discovered a relationship between the signs of the coefficients of a polynomial function and the number of positive and negative real zeros. So I'm going to just give you the rule, and then we're going to talk about it. We're going to do an example. It sounds confusing, but it really isn't. So it says the number of positive real zeros of p of x is the same as the number of changes in the sign of the coefficients of the terms, or it's less than this by 2 all the way until you get to 0. For the negatives for p of x, if you do p of negative x, the number of sign changes is a number of negative sign, negative roots, less by 2 until you get to 0. So what does that mean? Sounds confusing, but it really isn't. So let's look at example 2 on page 360. It says f of x. Remember, it's going to get really confusing. What are the roots? It's how many times it crosses the x-axis, how many zeros, how many x-intercepts. And we already learned the corollary that said, let's look at this one. Let me write it out for first. Minus 6x cubed plus x squared minus 8x plus 5. We said the degree is 6, so it's going to have 6 roots. It could be imaginary, it could be imaginary and real, it could be all real, or it could be a combination of both, or all imaginary. We don't know. We have to graph it. We can put it on our calculator and look at it and see the number of roots. This also includes the number of repeats. So we talked about the corollary of the fundamental theorem of algebra that said if it had degree of 6, it's going to have 6 roots. This includes complex roots and repeated, and you'll learn more about that later. So let's look at it. This is an implied positive. So positive, positive, one change here, negative, change here, a change here, and a change here. So I had 1, 2, 3, 4 sign changes, meaning I could have 4, 2, or 0 positive roots. Okay, doesn't mean they have to be real, but these are ors. All right, not exactly 4, not exactly 0, or. And then if I do f of negative x, meaning I simply put negative into the x. So when it's raised to an even power, it's still going to be positive, so this sign doesn't change. I have an odd, so negative raised to the 5th power is going to give me a negative. So we're going to change this to minus 3x to the 5th. Even, it's not going to change, so it's still minus 4x to the 4th. If I put a negative here, it's going to be a negative, so I need to change this to its opposite, so plus 6x cubed. Plus x squared, because it's even, so it's not going to change, and this is going to change to its opposite, because it's an odd degree. Plus 8x plus 5. Now let's look at all the sign changes. I went from positive to negative. Didn't change, whoops. Change here. Didn't change. So I had 1, I had 2. So that means I have 2 is what I got. So I have 2 or 0 negative roots, or my possibility. So now let's look at a chart. I'm not going to write this all out because it will take too much time, and I know you're in a hurry to get through this video. So I want to make it as short as possible. So let's look at this page 360. This is the same example I did. So we said we have the number of positive zeros, number of negative real zeros, number of imaginary, and total. So this total number is going to be 6, because I have a degree of 6. So they're all going to equal 6. So we said if we have our possibilities, we looked where were 4, 2, or 0. So let's go look at that, enter that. So we can have 4, 2, or 0 positive roots. So we said we could have 4 positive, and we said we could have 2 or 0 roots. So we put 4 and 2. That means it'll be 0 imaginary, because that has to equal 6. We have 4 positives and 0 negative roots, real roots, then we have to have 2 imaginary because it has to equal 6. If I have 2 positive real roots and 2 negative real roots, then I have to have 2 imaginary because it has to equal 6. If I have 2 of these and 0 negatives, then I have to have 4 because it has to equal to my degree of 6. If I have 0 positive, because I said I can have options 4, 2, or 0, then I have to have 2 negatives. I can have 2 negatives or 4 imaginary. If I have 0 positive roots and 0 negative roots, then they all have to be imaginary. It means it never crosses the x-axis. All right. So let's look at. Let's move on. Let's talk about finding the zeros. Okay. You can use the various strategies and theorems we've learned to find the zeros of the function. So what does that mean? So let's look at example number 3. It says find all the zeros of f of x equals x to the 4th minus 18x squared plus 12x plus 30. First, it has to be in degree order. What's this degree is 4. All right. So now let's look at the sign changes. I go positive, so there's 1, 2. So I have a degree of 4. So the positives, I have 2 sign changes. So it means I can have 2 or 0 positive real roots. They can be rational or irrational. Now let's put in f of negative x. So it's even, so it doesn't change. I don't have an odd. It's even, so that doesn't change. I have an odd, so that changes to its opposite. And then a constant doesn't change because there's no x. So I go from here to here. It's 1 change, no change, 2 changes. So I have negative, possible of 2 negative roots. So I can have 2 sign changes. So I can have 2 or 0. All right. So they want us to make a chart, and we're going to learn better how to do this. So we would have to factor it and set them equal to 0 to find the solutions. We know we have to have 4. We could have 2 or 0 positive real roots, 2 or 0 negative, means it's just a negative sign. All right. So if you look at the chart on page 361, they put them in, and they just happen to guess by accident, and they guessed the real solution. So if you look at this, let's see if I can move this up, right here. So they put in -3, and they use synthetic, this is synthetic division, and they have a remainder of 37, -37. So that's not a factor because you have to remainder of 0. They put in -2. Oh, we have a remainder of 0. So -2 is a factor. So is a solution, is a 0. So x equal -2. And remember, we have x equal -2. So I'm going to plus 2 to get the factor. So x plus 2 equals 0. Now, if we go back to it, we see in the synthetic division you had 1, -2, -14, 40, remainder 0. And we said, when you do this, this is what's left. These are the coefficients. And this is going to have, this is going to be your constant term. So x to the 0, x to the 1st, x squared, and x cubed. So you just multiply this. So you have 1x cubed minus 2x squared minus 14x plus 40 is what you have left. And then you can go one even further and factor it. And they put it in there and they get -4. So x equal -4, which is x plus 4 equals 0. And if you look at that chart, they have left in the synthetic division 1, -6, 10, and 0 is a remainder. So you have x to the 0, x to the 1, x squared. So you have x squared minus 6x plus 10. That's not factorable, so they use the quadratic formula. When they use that, they get 3 plus or minus I. So 3 plus or minus is 2 imaginary, These are both what? Negatives. I have two negative zeros, two imaginary. My degree of this is 4, so then I'm done. I have no more roots. And if you look at the graph, they actually show it. You can actually look at it and put it in your calculator and see that it only crosses at 2 places. And up here it kind of does this. It's imaginary. So these are our two x-intercepts, which are real solutions, and the other two are our imaginary. All right, I know it sounds confusing, but we'll go over this in class more. Now, we said in Chapter 4, we learned that the product of complex numbers is always a real number, and that complex root always come in conjugate pairs. So meaning, like this last one we had, if we have an answer, it's 3 plus or minus, it could be 5i over 2, or it could be under a square root with an I, because it's got the I. We said when we have the solutions, we're going to have 2 plus or minus. Okay, so if we look at x squared minus 8x plus 52 equals 0, it's not factorable, and we use the quadratic formula, and we get 4 plus 6i, and we get 4 minus 6i. So this applies to the zeros of a polynomial function as well. So for any polynomial function with real coefficients, if an imaginary number is a 0, meaning it's a root, it's a solution, it's a factor, its conjugate is also a 0. So basically we're saying if I tell you that it has a root of 3 plus 4i, you know it's also going to have a root of its conjugate, which is 3 minus 4i. Okay, so you'll have two roots. It's also 0. So let's look at it. So let's look at example 4. And it says write a polynomial function of least degree with integral coefficients. That just means coefficients of integers. The zeros, which include -1 and 5 minus I. So we're saying x equal -1, x equal 5 minus I. Well, this is a complex root, so its conjugate is also a root, which is 5 plus I. So now we're using algebra. So we get x plus 1. We're going to, remember it's two terms, so we're going to plus it to the other side. So we have x, so it's a positive, so minus 5 minus I. And we can distribute. We can rewrite this to say x minus 5 plus I. Again, I'm minusing this, so I have x minus 5 plus I, which is x minus 5 minus I. So those are its roots. And then we would multiply these. So we know these conjugate times its conjugate, we know that OI is going to, but we can just check this, right? So we're going to have x squared. We multiply all this out, we're going to end up getting x plus 1, and we're going to get x minus 5 squared minus I squared. And that's why we'd leave it in this form, because then you have a binomial that's easier to FOIL. So we're going to erase this part. We're going to leave it as a binomial, so then we can FOIL, and we don't have to worry about the OI because it's a conjugate, right? Anything times its conjugate, the OI's 0 out, and then we're left with just the first times the first and the last times the last. So let's finish doing this. So first times first, so we get x squared, and then last times last, negatives will be plus. What do we have going on here? We have 5 minus I times 5 plus I, which is simply x squared plus 25 minus I squared or plus 1. Now we can multiply that by x plus 1, and we simply get, we do it all right, and I'm sure I did some bad math here. Oh, I did. Oopsie. So anyhow, this, when you multiply this out, you end up with x squared minus 10x plus 26. I'll do it step by step in class, but basically you're multiplying this out, and then you multiply this out, and you end up with x cubed minus 9x squared plus 16x plus 26. I have a polynomial function. I had 1, 2, 3 factors, so I have a degree of 3, and I have all integer coefficients. Okay, so that's how I know it's correct. We're going to work on more. Do your problems, your homework. There, do problems number 2, 4, and 6 on this video. All right, and then we will see you in class.